Hello students, welcome to my channel, Chori Maths. Now in this question we have to find x. It's a series issue. So once we add everything in the series, this is what we are going to get. But what we are really interested in is finding the value of x. So let's do it this way. Now the first thing you will do here is to see that this x raised to power 0 is actually 1. Then we have plus x raised to power 1 plus x raised to power 2. Then plus dash dash dash, of course, then 2 plus x raised to power 11. Now this is what is on the left hand side. Now the wisdom there is once you add it, because it's a series, so we sum it. Once you add it, you are going to get what is here. So we're going to work the left hand side, then equate it and see how we can find the value of x. Now in working the left hand side, it's a series. So there are two things there. It is either it is a GP, geometric progression, or an AP, which is arithmetic progression. Now, but looking at it carefully, you'll find out that it is actually a GP. Now, if it's a GP, then we need some things in a GP. And the first thing that we need is we are going to need our T1, which is our first term. Now, in this case, first term is A and our first term is 1. So we have it as 1. The second thing we have to get, let's get our common ratio. Now, common ratio is gotten from this formula T2 over T1, or we can say it is T3 over T2, or we can say it is T4 over T3. So it's just ratios of consecutive terms, basically. So for us to get this, our R will be equals to, now let's check, we've picked the first and the second terms, which is x and 1. So it's going to be x over 1, all right? And because it is x over 1, the answer is x. Now, let me tell you something here. You see, we are going to actually make use of our R very well. And in this case, our R is x, which is actually greater than 1. So just take note of this. Put it at the back of your minds, okay? Then the next thing is to find n. And n is actually number of terms. We are preparing this because we are going to work with sum, okay? Sum of a GP. Now, how do we now get our n? Let me show you what to do. Now, if you come down here, you see that this is 11, and it is a consecutive thing where we have 1, 2, then we are going to have 3, 4, 5, 6, down to 11. But hey, we have one more term here. So it actually is going to be 11 plus 1. That is going to be our n, okay? Please let me take this off. Let me make it well, okay? So 11 plus 1. So that is our n. And it's equals to what? 12. Now we'll come down here and write our work. This is 12. Now the next thing we are going to do is to find our sum of terms. Now we have Sn is either a into 1 minus r raised to power n all over 1 minus r, or we have our Sn is equals to a into r raised to power n minus 1 all over r minus 1. Now if you check it, the condition here is that r must be less than 1 here and r is greater than 1. I remember I told you that I should take note of this. We know that our r is greater than 1, so we are going with the second, which is this. Now, so we'll now put in our values so that we are going to have S12 now, that is sum of the first 12 terms, is going to be 1 because our a is 1. Then we have r, which is x raised to power n, and the n, of course, is 12. So let me just replace it, minus 1. Then everything here all over what? X minus 1. Now this can be written as x raised to power 12 minus 1 all over x minus 1. Separating it, which I'll tell you why I'm separating it. I'm going to have x raised to power 12 all over x minus 1, then minus 1 all over x minus 1. So take note of this. Put it at the back of your minds. Then let's go back. Can you see the sum? Let me show you. Can you see the sum? Look at the sum here. So I will now go back and put in the value, or I'll equate it so that this will now be equals to x minus 3, then plus we have x raised to power 12 all over x minus 1. Now, having this, clearly you can see that once I collect like terms, this will go with this. So what I'm going to be left with will be minus 1 over x, x minus 1 is equals to x minus 3. Cross multiplying, I'm going to have x minus 3 into x minus 1 will be equals to minus 1. Expanding it, I have x squared. Then we have minus x minus 3x, then plus 3. Then bringing 1 over is going to be plus 1 is equals to 0. Hence, this is going to be x squared minus 4x plus 4 is equals to 0. Solving it quadratically, I'm going to have x squared. Then the factors that I need will be minus 2x, then minus 2x. Then, of course, we have our plus 4 is equals to 0. Factorizing further, we have x into x minus 2. Then I have minus 2 into x minus 2 is equals to 0. So I have x minus 2 down into x minus 2 is equals to 0. So I'm going to have x minus 2 all squared is equals to 0. So that x is equals to 2, but twice. All right. Now, my final answer is x is equals to 2. I know it's very interesting. So keep watching my channel and don't forget to subscribe.